Quick, graph one period of y equals 3/2 times the sign of the quantity 1/3 x minus pi over 2 minus 1 by hand. This is part of the family of functions series. You will need paper and straight edge, and we suggest you create grids similar to the ones shown here. Press pause as needed anytime during the video. Again, we're graphing just one period. We first need to analyze this. Which parameters affect the y values? That would be the 3/2 times and the minus 1. 3/2 times multiplies each y value by 3/2, and minus 1 subtracts 1 from each y value. And by the order of operations, remember that we multiply first and add second. So let's look at the y values of the points of interest. 3/2 times the y value minus 1 is what we're going to be doing. The maximum normally has a y coordinate of 1, so we're going to multiply that by 3/2 minus 1, and so we'll get 3/2 minus 2/2, which is positive 1/2. Points of inflection normally at y equals 0, but we got to multiply that by 3/2 and subtract 1, and so we're going to get 0 minus 1, which is negative 1. The minimum normally is at y equals negative 1, but again, multiplying that by 3/2 minus 1, we get negative 3/2 minus 2/2 is negative 5/2 for the new minimum. And here's a quick summary of those. Now, which parameters affect the x values? That would be the 1/3 times and the minus pi over 2. Remember that the beginning of a period normally starts when the argument is equal to 0. So we're going to set that argument equal to 0 and solve for x to see where this one starts. So 1/3 x minus pi over 2 equals 0. Solve for x, pause as needed. Multiplying through by 6 will clear out the fractions. 2x minus 3 pi equals 0, so let's go ahead and add 3 pi to both sides, and then divide both sides by 2. So our first period is going to begin at x equals 3 pi over 2. The end of the period is normally when the argument is equal to 2 pi, a period away. We're going to set this argument equal to 2 pi and solve for x. Pause is needed. First of all, we will multiply each term by 6. That will clear out the fractions. Add 3 pi to both sides, and then divide both sides by 2. And this is when the period will end at x equals 15 pi over 2. Now, using all the values listed here, let's decide how to mark the units on the x-axis and the y-axis. Pause to think about that. Resume when you're ready. So we're going to suggest marking every pi over 2 on the x-axis to help us get this. And we're going to suggest marking the y-axis from negative 3 to positive 1, showing each half unit. Pause to do that. Notice the axes are not drawn square, but there's our pi over 2 markings along the x-axis, and also 1/2 along the y-axis. Now let's put all this together, almost like putting a puzzle together. We've got all the pieces. Let's put this together. I prefer drawing dotted horizontal lines at the max point of inflection and minimum. So I'm going to draw a horizontal line at y equals 1/2 for the maximum in blue. A dashed line at y equals -1 for the points of inflection. And a minimum at y equals -5/2 for the minimum. Recall the graph of y equals sine of x, which normally starts at a point of inflection. But for this one, our period starts at 3 pi over 2 for the x value, and our point of inflection value is -1, so we're going to plot the point 3 pi over 2, -1. There it is. The end of the period, well, we end at 15 pi over 2. It's also a point of inflection, so that'll be 15 pi over 2, comma, -1. So we'll plot that point out here. Our point of inflection here is going to be halfway between these 2 points, as it is halfway between these two. And so that's going to be at 9 pi over 2, comma, -1. You can see that those are equidistant there. This maximum halfway between these two will be somewhere up here along this dotted line here. So going halfway, that's at 3 pi, comma, 1/2. And then finally, our minimum is going to be halfway between these two, down at y equals -5/2 for the y value. So that's 6 pi, comma, -5/2. Pause is needed. Now we can connect the points as a sine wave, concave down, then concave up, and we're just getting one period. That's enough for this one. Equivalent forms, we factor out the 1/3, and we can see that the phase shift is right 3 pi over 2, and we can see that on our graph. We also have the -1 for the point of inflection. We can see that right there. The period is inversely proportional to this coefficient, so dividing by 1/3 is the same as multiplying by 3. So the period is 6 pi, and we can see that it starts here and ends here, and that is a distance of 12 pi over 2, or 6 pi. Pause is needed. Now you try one. Graph one period of this function here. You will need to change the units. Pause is needed. Resume when you're ready. So we listed a lot of the information here, where the max, the point of inflection, and the minimums occur, where the beginning of the period is, where the end of the period is. We hope that's enough to help you check your answer.